Hello, everybody, and welcome back to Coffee Break, the show we break down interesting topics, all within the time it takes you to enjoy a few cups of coffee. As always, my name is Clifford Swartz, and today we're going to be breaking down wireless charging in automotive solutions. Today I am joined by two very special guests. Number one, David Schellenberger. How you doing?
It's fine, thanks, Clifford.
David is a automotive marketing manager here at Microchip, and my second guest, also from Microchip as we all are, is Vijay Bapu, and he's joining us over Skype. How are you, Vijay? He's muted, but that's okay. Anyway, before we dive into wireless charging...
Good morning, everybody.
Good morning. Hi. Before we dive in, I'm going to throw it back over to the booth where we're going to see Michael Pierce again, and he's going to tell you guys how to participate. How you doing, Michael?
Very good, thank you, Clifford. So, welcome again to Season 2, Episode 2, and we're going to be talking about the wireless charging. And so, thanks for everyone for joining us. And we're broadcasting live on LinkedIn, Facebook, and YouTube. Please submit your questions in the chat, and we will answer them at the end of the presentation. And we also have some experts online that may answer your questions beforehand as well. Cool. If you like it, please share it. We love you sharing the show. The more people we get, it's better for us. And also, if we don't get to your questions, please email us at livestream@microchip.com. Back to you, Clifford.
Cool. Thank you very much. So, like Mike said, if we don't get to your questions, we're going to make sure it gets out to David and Vijay, and we'll hound them until they answer it. So, today's topic, wireless charging. It's kind of like a magical thing in my mind. We just place a phone down on a car dashboard or some sort of device, and an hour later we have a charge. Do you mind breaking down what's actually happening when we're doing any sort of wireless charging?
Yeah, sure. So basically wireless charging is just the transfer of power over a short distance via inductive coupling. So it allows you to do things like charge the batteries of electronic devices, as you mentioned.
Right.
And in terms of automotive, in-vehicle wireless charging deals specifically with charging a smartphone. So you're able to do that without having to make a physical wired connection to a charging port on your dashboard or center stack or center console, something like that.
So it basically removes wires from
Exactly.
an already like compact sort of system in my mind.
Exactly.
I'm sitting down in a car, I don't want to have to deal with wires getting caught in anything.
Yeah, it's mainly a convenience thing. You can just lay
Makes
your
sense.
phone down. You don't have to worry about wires or anything like that.
So I believe one of the main things in automotive and wireless charging, correct me if I'm wrong, is the CHI standard, right?
That's right. That's right. So the CHI standard is the de facto wireless charging standard. It's been around for more than a decade. The Wireless Power Consortium developed it more than 10 years ago, and it's been widely adopted across the smartphone, tablet industry, and it's also been widely adopted by the automotive industry as the standard for in-vehicle wireless charging.
Right.
Now there's a new version of the spec that's coming out early next year, version 1.3, and Microchip, being a part of the consortium, is helping to drive that new specification, helping to develop that. Some of the changes for that spec, one of the things is it's going to be authentication added to it, and Microchip has a long history in security in terms of cryptography, authentication, things like that. So we're going to be a key player in helping to drive that part of the specification. And another feature that's being improved in this specification is the foreign object detection. And we have a DSPIC digital signal controller that has a lot of key features that can help designers meet those new specifications.
So I have a question for you, Vijay. When I hear authentication and authorization, I associate those words immediately in my mind with security. Is that right?
Yeah, that is correct. Yeah, that's a good point. And yeah, like you mentioned, this includes authentication. Basically, everyone wants to charge their phones faster, right? I mean, if you want to charge your phones faster, you need higher power transfer. So currently, most phones accept power only in the range of about 5 to 9 watts in steady state because of safety reasons. To charge faster, we can increase transmitter power to 15 watts, which the standard actually allows right now. But before 15 watts is requested, for safety reasons, the phone manufacturer wants to make sure that the transmitter is indeed a certified and an authenticated transmitter. This is where authentication comes into the picture. The phone sends a challenge question. The charger with the secure element solves the challenge question and sends a challenge response back to the phone. Based on the appropriate response, the phone says, hey, okay, this is an authenticated Qi certified transmitter, so I will go ahead and request 15 watts of power.
Cool. So it's all about keeping not only the device, but also what you're using to charge the device safe, right?
Yes, exactly. In addition to the implementation of the authentication protocol for Qi 1.3, there is a big undertaking from the infrastructure standpoint for the implementation of authentication. I mean, in this process, there is it's fairly involved. There is the charger manufacturer, basically, whoever is manufacturing the charger. There's a manufacturer certificate authority, a root certificate authority, and the licensing authority for this authentication. So Microchip can be the manufacturer certificate authority as well. So Microchip has years of experience with security, and we can manage all the complexities in the process for you.
Cool.
So essentially, you can look at Microchip as like a one-stop shop for your Qi 1.3 implementation.
So speaking of a one-stop shop, I think we have a specific example of a Microchip solution for wireless charging.
Yeah. So Microchip basically offers everything you need to develop a wireless charging system for automotive use. We have the hardware, the firmware, the tools, and the technical expertise to help you design, develop, qualify, certify your design. What's showing on the screen now is a block diagram of a reference design based upon Microchip components. You can see we offer all the analog that you need, the power management piece, the voltage regulation, the gate drivers. We also have the CAN transceivers. We have LIN transceivers as well, if that's needed. We have the authentication companion device that VJ was referring to earlier. But the key piece of the system is the DSPIC digital signal controller. That's the heart of the system. And that has a lot of unique key features that will help you develop a really innovative wireless charging system.
So just so I'm reading this right, every red box is a Microchip part?
Correct. We offer different solutions for each of those blocks.
Cool. So like you said, the DSPIC is the center and also the largest block. So as one of the most important pieces, can you guys talk to me a little bit about the advantages about why somebody would want to use a DSPIC?
Yeah, I can take that. Yeah. So yeah, essentially the DSPIC enables a very highly flexible solution. Yeah, so the DSPIC 33C core and the high-speed ADCs and the high-resolution PWMs in the device provide the performance and flexibility needed to create, say, for example, new transmitter types, or if you want to optimize the transmitter efficiency and implement very reliable foreign object detection schemes. So this is very helpful there. And you can also implement digital demodulation with the high-speed ADCs and the digital filters in the DSPIC. Yeah, these are all AEC Q100 grade 1 qualified parts. So they're qualified up to 125 degrees C.
Cool.
And you have flexibility in terms of the flash size in the same family of devices. So for example, you can start your development with a larger device as a development platform, and then you can move to a smaller device with the appropriate flash size for a specific OEM based on your system architecture. So the software in the device is easily portable across the different devices in the family.
Cool.
And we also have the dual core device in this family here, like on this slide. For example, on one core, you can implement the Qi stack, and on the other core, you can implement CAN, NFC, and any other stack that you have. You can have parallel development across multiple teams in the two cores, and you can essentially seamlessly integrate them at the end of the development.
So
you can also have parallel...
Sorry, you finish.
Yep. Yeah, that's just one other thing was you can also have parallel instruction execution during runtime, which kind of speeds up some instruction execution.
Cool. So I have two questions for you guys. Firstly, we've mentioned foreign object detection a couple of times. Why would somebody actually want that? Somebody could think that if it's secure, if we can authenticate a cell phone, then there's nothing else needed. But where could we need that?
Yep, so that's a very important question. And the foreign object detection is one of the most important features in any wireless power system. So for example, when you're charging, if you have a coin in the vicinity of the charging coils or the transmitter coils, before the charger starts to transmit power, or if the coin, for example, slides into the vicinity of the transmitter during power transfer, I mean, which could happen in the case of a moving car environment.
Right.
Yeah, so you want to make sure that the power is not unnecessarily transmitted to the coin instead of the phone. I mean, if you're transmitting power to the phone, you're essentially heating up the coin, and it could cause a dangerous safety hazard with a very hot coin in the vicinity of your phone and your keys and things like that.
So safety number
So
one,
essentially,
but also it saves you guys power, right?
yeah, exactly.
And then my second question is that I see that we have CAN-FD listed as one of the mentions in the dual core functioning slide. I'm not as familiar with automotive things as you guys, but CAN-FD is the new CAN protocol?
Yeah, so CAN-FD has been around for a few years now, but it's an improvement over the traditional CAN 2.0. It stands for CAN Flexible Data Rate. And you know, it has several advantages. It has higher speed. You can get up to 5 megabits per second transfer speeds. More data bytes per frame. It's more reliability, improved cyclical redundancy check. Yeah, the main advantage over CAN 2.0 is the higher speed.
And so that's something that's already adopted by the automotive markets,
Right.
but moving forward, if you're going to be designing anything automotive, it'll be CAN-FD, right?
Yeah, if it's got if it's on the CAN bus, it's likely going to be
Cool.
CAN-FD.
So where can people get started if they wanted to begin designing? Do we have any reference designs or things like that for people? We do.
Yep. So you can contact your local Microchip representative to find out more about how you can get one of these boards. Yeah, so these boards will be made available on a larger scale once we finish certification after the 1.3 specification is final. And if you don't have a Microchip sales contact, yeah, just please put in a request via microchip.com/support, and we will make sure to reach out to you.
Cool. Is there anywhere else you guys want to direct people for guidance, web pages that we have for people?
Yeah, you can see all of our wireless power solutions at microchip.com/wireless-power. And if you're looking for more general automotive solutions, you can go to our Automotive Design Center, which is microchip.com/automotive. So you can find out about all of our products that are qualified for automotive. You can see different automotive applications, app notes, tools, things like that.
Nice. So we're going to make sure that we have all those links in the description and comments, but I think that's it for the presentation portion. Mr. Pierce, what questions do we have from the audience?
So we have a few questions. First one, how many phones can be charged at the same time?
That's a good question. David, do you want to take that or VJ?
I can take that.
Okay.
So I can take that. So currently, the way the Qi standard is implemented is that on one charging pad, you can charge essentially one phone at a time. But there are ways to have multi-charge capability. So you can essentially control two charging pads with one controller. So in that case, you can charge two phones at one time.
Cool.
So these are some of the typical transmitter types that have been approved by the consortium.
Okay, and then the next question, which is related to phones as well, can every smartphone work with this charger?
If you
All
want,
Qi-enabled smartphones can work with this charger. So essentially, all the major smartphone manufacturers like Apple, Samsung, Google, Huawei, all of them have Qi-enabled smartphones. But some of the older models, which were released a few years ago, they do not have the Qi receiver functionality. So you won't be able to charge those. So, but as we go, you can see more and more adoption of this. And soon we expect almost every major smartphone continuing and implementing Qi wireless power.
I think I've seen also some third-party companies that make cases,
Right.
where you can just plug your phone into that case, and that case has the the receiver to allow it to be wireless.
So even if your phone doesn't natively come with it, you can just plug it in and you're good.
Yeah, you have to buy the special case that plugs into your phone.
That's cool.
Yeah, that's good.
Okay, we have more.
Good.
So what makes this wireless power solution well suited for the automotive environment? And do the parts need to be more robust?
Yeah, so all automotive manufacturers require automotive grade components. They need to be qualified to the AEC Q100 or Q101 specification or standards. And all of the products that we're talking about today do meet that. Microchip has been a leading automotive supplier for more than 25 years. We're a top 10 semiconductor supplier to automotive, so we have many products that are qualified for automotive. We know how to do it. We've been doing it for a long time, so it is a requirement. So you do need to select automotive grade parts, but that's not an issue if you choose Microchip.
Cool.
Okay, the Qi standard is changing. How does the DSP-based solution help adapt with the changing requirements?
Yeah, that's a great question. Yeah. So yeah, like you mentioned, the Qi standard is changing. So 1.3 is coming up in early next year. And then in addition to that, there'll be a few minor versions coming up, which will implement certain things like open air queue measurements and faster communication speeds and things like that. And the key part that I want to mention is that the DSP33 core, which is very programmable and a very flexible software architecture that we have set up in our DSP. And of course, the high-speed peripherals enables the very effective implementation of these feature upgrades. So while these parts are in the field, you can make software upgrades for some of these new feature additions. So that's a great question.
Okay, another question. How many vehicles use it already?
Oh, there's well over 100 models today that offer wireless charging either as a standard feature or as an option. With systems like this, you typically see it starting out in the higher end vehicles or the higher end trim levels, and then eventually proliferates down into the medium and lower end vehicles. But we expect within a few years that half of the new cars coming out will have either a wireless charging as a standard feature or an optional feature, and eventually it's going to get to the point where it's a standard feature on every car that comes out.
Okay, and a slightly more tricky one.
Oh.
Can you charge a laptop in the car?
So that at this point, there are no laptops which are enabled with the Qi protocol. But there are companies and the Wireless Power Consortium that are working on the specification, but I mean, this is not possible right now. So we will have to wait for at least a few years for this.
Cool.
And the last one?
Sure.
How would one achieve proper alignment of the device on the charging pad, given that phones have different dimensions, different placement of the inductive coils within the device?
DJ
So
question.
could you repeat that question, please?
So how would one achieve proper alignment of the device on the charging pad? Given that your phones are different shapes and sizes and the coils are in different places inside the phones.
Yeah, that's a good question as well. So this is one of the things with inductive charging. So typically with inductive charging that's implemented in Qi, so you have to get good alignment between the transmitter and the receiver coil. So in that case, so for example, when we have a 3-coil design, So we have 3 coils essentially, which can on the transmitter, which can power the receiver. So based on the positioning of the phone on the charging pad, you can energize the appropriate coil. So by increasing the number of coils on the transmitter, you get a wider charging area. So even if the phone is sliding around on the charging pad, at least one of the transmitter coils will couple to the phone and charge it. So you can increase the number of coils, and that's some programmability that we can enable in the solution, and you can get a larger charging area based on your specific requirements.
So I have a really quick follow-up question, if we can sneak that in. So the greater the distance, the less actual efficacy of the charging, right? VJ?
Yes, you can say that. Yes.
And so is there a certain threshold that needs to be made before it actually couples to your phone? Or how does that work?
Yes, so typically most inductive charging solutions and also what Qi implementation, the charging distance is in the range of about 5 to 9 or 10 millimeters. So there are certain newer topologies where you can charge through, for example, changing a tabletop, and those are fairly new. We need to manage a few things in terms of the thermals and things like that. But typically, this is for maximum efficiency in an inductive charging system, you need to be in the range of between 5 and 10 millimeters.
Cool. Mr. Pierce, was that our very last question?
Just double checking for everyone.
Okay.
And actually that efficiency question just came up. What's the efficiency of the power transfer? It was a question that just popped up on YouTube. So.
Okay, yeah, that's a good question again. So, yeah, the efficiency depends on quite a few things. It depends on the components in the charger, the coupling distance, and also the coils and some of the components on the receiver. So, like I mentioned earlier, the DSP-based solution, you have a lot of flexibility, and you can optimize the efficiency with this solution. And typically, for any inductive charging solution, typically charging is measured from DC input on the charger side to the DC output on the receiver side, and roughly 80% is a good number to target and achieve for that particular input-output positions.
Cool. Well, then I think it's about time to wrap up. If we didn't get to your question, make sure to email us at livestream@microchip.com. And like I said in the beginning, I'm going to make sure that it gives that to David and VJ, and they will answer your question. I'd like to give a huge thank you to our 2 guests, Mr. Schellenberger and Mr. Bapu. Hope you guys had fun.
Yeah, that's great.
Thank you very much.
Thank you. Yeah, it was great being on here.
Absolutely. Thank you to everybody behind the camera here at Microchip that has helped produce this and make this a thing. And then finally, I'd like to give a huge thank you to you, the viewers, because without you, this wouldn't be happening. So yeah, in 2 weeks, we'll be doing another coffee break. We're going to be talking about our tool, MAD, MP Lab Analog Designer. I think you guys will go mad over it. And anyway, I hope to see you there. See you.